This is Chapter 11 homework, question number 2, dealing with conservation of momentum. The problem states a nucleus of uranium-238 ejects an alpha particle transmuting into a nucleus of thorium-234. If the alpha particle is ejected to the right at 1.42 times 10 to the 7th meters per second, determine the speed and direction of the recoiling nucleus. So here, right, it's all about conservation of momentum. That being said, we come back to this. Momentum initial must be equal to momentum final. And that's momentum in the sense of both of our objects of interest, sort of. We've got, here's my small alpha particle, here's my thorium-234 nucleus. Problem gives us, right, we get mass of this big guy, that big thorium, we get the mass of our alpha particle and the velocity of our alpha particle. So to start off, we can throw these guys into this piece right here, into that mass 1 times velocity 1. But now thinking sort of ahead, this guy has 0 velocity, it's stationary, so it has momentum. So it's going to spit out a 0. Its momentum value is going to have a 0. So that doesn't hold up if we set those equal to each other. Our momentum final is not equal to our momentum initial. So we can move this guy around, divide by mass to solve for its velocity. I'm calling this guy object 2, this guy object 1 in this scenario. So we can divide by the mass of this to end up having it directly spit out our velocity. So that's kind of what I did here. I moved around the formula to make it a bit easier on ourselves. Now we can straight up just plug and play this. I have mass, velocity, and mass. I have one equation that has 4 unknowns, but I have 3 of them. I can solve for one of those unknowns. So I'm going to plug this guy in right here. The mass of our mass of our alpha particle is going to be 6.64 times 10 to the negative 27th kilograms times its velocity, 1.42 times 10 to the 7th meters per second. We can divide this by the mass of that guy to, in one step, in one go, get the resultant velocity of this. The mass of our thorium isotope is going to be 3.89. We're calling it 3.9 times 10 to the negative 25th kilograms. Here, those kilograms will cancel. I will get strictly a number in terms of meters per second. This gets me a velocity. It spits out our number being 2.42 times 10 to the 5th meters per second. That is our final answer. Now, before we end off, this question asked about the direction of the recoiling nucleus. The thing is, here, it's just one directional. We don't have any angles going on here. The direction that this guy will end up moving in is going to be the same direction that this is fired in. So that's it for this. I think the best way to think about this is in space. If you were to throw a golf ball at a basketball, I've got object of interest, a body with a higher mass that's stationary, that is being affected on by a lower mass object that moves at a high velocity. And then that gives us a bit of a smaller velocity, but the product of those must be equal. So, yeah, there's it for question 2.